Sound recording technology has come a long way since its invention in the 19th century. While its best known uses might be bringing you your favorite music and podcasts, there are many surprising ways sound are being used in scientific research. So in this video, we're going to talk about the 5 mysterious sounds recorded in space. The video is going to be amazing, so make sure you stick to the end. Number 5, a black hole. In space, nobody can hear you scream, right? Well, not exactly. It is true that sound needs a medium to travel, such as air or water, but space is a vacuum and does not have these. So it should be dead silent. But in 2022, NASA proved this is not entirely accurate. Space is not a complete vacuum chamber, so it's not completely silent. Galaxy clusters contain gases that can provide the medium for sound waves to travel. Because of this, NASA was able to record the sound emanating from a black hole. They had to amplify it many times since the sound was at a pitch some 57 octaves below middle C, far too low to be heard by human ears. If having to scale the note up 57 times to be able to listen to it sounds like a lot, consider that in frequency terms, it had to be scaled up about 288 quadrillion times higher than the original. A quadrillion has 15 zeros. Number 4, sounds of a comet encounter. The electromagnetic sounds recorded by Rosetta during its cometary encounter required considerable processing to make them audible to human ears. But when an earlier probe, NASA's Stardust, flew past Comet Tempel 1 in 2011, it heard something much closer to real sounds. While sound waves can't travel through space, dust grains and larger debris breaking off the comet could be heard when they hit the probe's protective shield. According to NASA, around 5,000 impacts were detected over an 11-minute period, as the spacecraft was pelted by fragments of dust and ice. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now, let's get back to our topic. Number 3, Voyager crossing into interstellar space. This sound isn't a real-time recording, but rather an audio version of a graph of the Voyager's plasma wave science observations of several months spanning 2012 to 2013. These readings mark the period at which scientists believe Voyager exited our solar system's heliopause, the area in which the pressures from outside our solar system force what's left of the sun's solar wind to turn back. In effect, this is the point at which Voyager left the solar system, the first human-made object to do so. We have some ideas about how far Voyager will need to get to start seeing more pure interstellar waters, so to speak, said Stella Ocker, a PhD student at Cornell University in Ithaca, New York, and the newest member of the Voyager team. But we're not entirely sure when we'll reach that point. This detection offers us a new way to measure the density of interstellar space and opens up a new pathway for us to explore the structure of the very nearby interstellar medium, Ocker said. Number 2, Jupiter's bow shock. The Sun emits a steady stream of charged solar wind, which can be repelled by a strong magnetic force, say the magnetic field of a large planet. When the solar wind meets this strong magnetic force surrounding a planet, it is deflected and all its energy of motion is converted to thermal energy. This energized region is known as a bow shock, which borrows its name from a similar phenomenon in aerodynamics. The sound of passing through this region was recorded by the Voyager spacecraft. Number 1, the Sun. A lot happens inside the Sun. Eruptions, waves bouncing around, solar flares, and more. But human eyes are not sensitive enough to see them, and even with the visual technology scientists have, they still cannot see what is happening inside. Instead, they use vibrations produced by the Sun's waves and eruptions and sonify them in order to learn more about the center of our solar system. This research has been led by the European Space Agency and NASA, who have been capturing vibrations produced by the Sun's movements for over 20 years. The vibration data is cleaned up to remove, among other things, the sounds of spacecraft, hopefully man-made. The frequency is then ramped up by a factor of 42,000 to make it audible to the human ear. So that's it. Please like, share, and comment your thoughts below if you like this video. Remember to subscribe to see our next video. Stay safe and we'll be back soon with another video.